In this video, we are going to discuss De Moivre's theorem, Pyqs, Vsaqs. The question is, if 1 omega square are the cube roots of unity, find the value of 1 minus omega plus omega square whole cube. So here in the solution, given that 1 omega square are the cube roots of unity, See, when 1 omega square are the cube roots of unity, we know that, so 1 plus omega square, which is equal to 0, and also omega cube, which is equal to 1. So we know these two conditions. We know that 1 omega square are the cube roots of unity, 1 plus omega square is equal to 0, and also omega cube is equal to 1. But here we have to find the value of, therefore, 1 minus omega plus omega square, 1 minus omega plus omega square whole cube. So which is equal to, so you consider that 1 plus omega square. See here, so we have 1 plus omega square, which is equal to 0. Now from this we can write 1 plus omega square is equal to minus omega. See, already here 1 plus omega square considering, this is rewriting as 1 plus omega square minus omega, so whole cube, which is also can be written as 1 plus omega square minus omega. See here 1 plus omega square we can replace by minus omega, so that's why here which is replaced by minus omega, and minus omega here already, so whole cube. So which is equal to minus 2 omega whole cube. So which is equal to, further we can write as minus 2 whole cube into omega cube. See here minus 2 whole cube into omega cube. We know that omega cube is equal to 1. So minus 2 whole cube is equal to 8. So this is minus 8, and also here odd power. Minus 2 whole cube is minus 8, and omega cube is 1. So finally we get minus 8. So therefore the value of 1 minus omega plus omega square whole cube is equal to minus 8. So like this we can find the solution. In this video we are going to discuss De Moivre's theorem, Pyq, Vsaqs. So many times repeated in the examinations. The question is, if 1 omega square are the cube roots of unity, prove that a plus b into a omega plus b omega square into a omega square plus b omega, which is equal to a cube plus b cube. Now given that 1 omega square are the cube roots of unity. 1 omega square are the cube roots of unity. So we know that, so the conditions are 1 plus omega square, which is equal to 0, and also here omega cube is equal to 1. See what they are given to prove that. Here taking this LHS, so LHS is given that a plus b into, this is a omega plus b omega square into a omega square plus b omega. So see here, now which is equal to a plus b into, here these two are multiplying. So how to multiply these two are with a omega multiplying this is, that means a omega into a omega square, so plus b omega, and also plus with b omega square, so multiplying this is a omega square plus b omega. So multiplying with a omega, this a omega square plus b omega, and also with b omega square, multiplying this is a omega square plus b omega, now which is equal to a plus b into, we get a omega into a omega square, these two are multiplying, we get a square, and omega into omega square is omega cube, plus again these two are multiplying here, so a omega into b omega, that is ab omega square, and plus again this is multiplying with that, so ab omega power 4 here, ab omega power 4, and also this is multiplying with this, so we get b into b is b square into omega square into omega is nothing but omega cube. So now we know that omega cube is equal to 1. So see here, a plus b into here a square omega cube, so that is a square into 1 plus ab omega square and ab omega power 4 we have. So that's why here if you ab omega square writing as it is, and plus ab into omega power 4 is writing as omega cube into omega, plus b square into omega cube is 1. See, we have here a plus b now, which is equal to, so here a plus b, so which is equal to a plus b into here a square, and plus ab omega square is writing as it is ab omega square, and plus ab omega cube is 1, so that's why ab into 1 into omega, that is ab omega plus b square into 1, so that is b square. See, clear? So now here, so if you observe that a plus b into here a square writing as it is, and here from these two terms ab is taking common, so when you take ab common we get here omega square plus omega plus b square. So see here, already we know that 1 plus omega square is equal to 0. So we have here the condition is 1 plus omega square, which is equal to 0. So from this omega plus omega square, which is equal to minus 1, so that's why here, so which is equal to a plus b into, so here a square plus ab into this omega square plus omega is replaced by minus 1, so minus 1 ab into minus 1 plus b square. So finally which can be written as a plus b into, so a square minus ab plus b square. See, we have a plus b, we have the algebraic identity, so that is a plus b into, so a square minus ab plus b square. So what it is equal to? It is equal to a cube plus b cube. So that's why here we get a plus b into a square minus ab plus b square. So which can be written as a cube plus b cube. So which is only the RHS we require to prove. So therefore LHS is equal to RHS. So like this we can prove the given problem. In this video we are going to discuss De Moivre's theorem, Pyqs, Vsaqs. Question is, if 1 omega square are the cube roots of unity, then prove that 2 minus omega square, 2 minus omega power 10 into 2 minus omega power 11, so which is equal to 49. So see here, the solution also given that 1 omega square or the cube roots of unity or the cube roots of unity. So we know that 1 plus omega square, which is equal to 0, and also omega cube is equal to 1. We know these two conditions. See, now I am taking LH is here, very simple one. So this is 2 minus omega into 2 minus omega square into 2 minus omega power 10 into 2 minus omega power 11. So this is LHS. So now here writing 2 minus omega into 2 minus omega square, so which is as it is, and here 2 minus omega power 10, so this is writing as omega power 9 into omega, and also this is writing as 2 minus omega power 9 into omega square. See, like this, right. So now, however, 9 plus 2 is 11 and 9 plus 1 is 10. So why writing like this means here further 2 minus omega into 2 minus omega square into 2 minus this omega power 9 can be written as omega cube whole cube into omega, and also again here 2 minus, so this is omega cube whole cube into omega square. See, we know that omega cube is equal to 1, so that's why here which is equal to 2 minus omega into 2 minus omega square into 2 minus, this is 1 whole cube, that is 1, so 1 into omega, this is 1 into omega, and again here 2 minus, so this is 1 into omega square. So finally what we get here, this is equal to 2 minus omega into 2 minus omega square, so into 2 minus omega into 2 minus omega square. See, observe here 2 minus omega or in the product 2 times. That means 2 minus omega whole square we can write. So further which can be written as, so which is equal to 2 minus omega whole square, and also 2 minus omega square and 2 minus omega square. So that is also 2 minus omega square whole square. So further what we can write, this is like a square into b square we can write. So 2 minus omega into 2 minus omega square whole square we can write. So further, now if you simplify this, multiplying with 2, this is 2 minus omega square, and here minus omega into 2 minus omega square, so whole square. See, observe here, so we have this is equal to 2 into 2 is 4, and here minus 2 omega square, and here minus 2 omega, and minus into minus is plus omega cube whole square. See, again what I am doing is in these two terms, so taking minus 2 common, so then we have here omega square plus omega, and plus we know that omega cube is 1 only here, already we have. So now already we have 1 plus omega square, so which is equal to 0, 1 plus omega square, which is equal to 0. From this omega square plus omega, so which is equal to minus 1. So that's why here it can be written as, so 4 minus 2 into minus 1, so plus 1 whole square, so which is equal to 4 plus 2 plus 1 whole square. So finally we have this is 7 square, so 7 square is equal to 49. So which is only the we have to prove required thing here in the right hand side. So therefore LHS is equal to RHS. So like this we can prove very simple